Hello everyone. In this video lecture, we are going to see some topics under measurements and instrumentation in the subject Basic Electrical and Instrumentation Engineering. In this lecture video, we are going to cover the topics Introduction to Measurements, next types of measurements, then characteristics of measurement, then types of standards, then types of errors, then moving coil instruments and moving iron instruments. Very first, we are going to see the definition for measurement. What is measurement? It is the comparison between a predefined standard and the quantity to be measured. Predefined standard is the apparatus or the measuring tool that we are going to measure a unknown quantity. Then the types of measurements are electrical measurements, electronic measurements and mechanical measurements. In electrical measurements, we can measure voltage, current, power, energy using voltmeters, ammeters, wattmeters, energy meters, etc. Similarly, in electronic measurements such as CRO, IC tester comes under electronic measurement category. Similarly, the weighing machine, speedometer, accelerometers, these are the examples of mechanical measurements. Next, types of measuring instruments. Indicating instruments. In some instruments, they indicate the reading only by using a pointer over the graduated scale. In some instruments are called recording instruments. They not only indicates the reading but also it records the reading in a graph sheet or by means of a XY plotter, etc. More than that, in some instruments are called controlling instruments. They not only measure the parameter but also it controls the parameter by means of some control mechanisms. For example, we can consider the water level indicator, temperature control, etc. Next, we shall see about the characteristics of measuring instruments. There are two types of characteristics. One is static characteristics and dynamic characteristics. What is meant by static characteristics? It is the characteristics that is required for any measuring instrument while measuring a unvarying quantity, or it is the quality of the measuring instrument required while measuring a constant quantity. Let's see the characteristics one by one. Very first, number one, sensitivity. It denotes the smallest change in the measured value to which the instrument responds. If a measuring instrument can able to respond for even a very small input change, it is called, you can said to be that instrument is having a good sensitivity. Sensitivity is expressed as the ratio of infinite small change in the output to the infinite small change in the input. Then number two, linearity. It is the ability to reproduce the input characteristics linearly. If the output varies linearly with respect to input, it is said to be linearity. Number three, precision or accuracy. We may think that precision and accuracy are almost the same, but there is a small difference between precision and accuracy. First of all, what is accuracy? It is the degree of closeness to the true value. If the true value is 5 volt and if we are getting the measured value around 4.9, we can say that is having a good accuracy. Similarly, what is precision? It is the consistency or repeatability of measurements. If the true value is 5 volt and you are getting a repeatability of values such as 4.8, 4.9 or 4.9, 4.9 like that, we can say that measuring instrument is having a good precision. Next is threshold. If the output changes only after a minimum value of the input quantity is varied, it is called threshold. In some instruments, if you are varying the input quantity from 0 to maximum, only after some input quantity is varied, there will be a change in the output. That is called threshold. It should be minimum. It should be minimized. Next is resolution. Resolution is the smallest measurable input change that can be detected. If a measuring instrument can able to measure a very small input change, can able to detect even a small input change, it is called resolution. Then hysteresis. It is the mismatch between the input and the output curves. There should not be any mismatch between the input and output curves. In sometimes there may be a mismatch will occur due to friction, damping or spring tension, etc. Otherwise, the hysteresis loop will be a proper curve. The next is range and span. We have to select the measuring instrument for the suitable measurement. So in such a way, we have to select the correct range and span of the instrument for the corresponding measurement. That also determines the quality of measurement. Then last one, input impedance or loading effect. In some measuring instruments, the transducers that is present inside the measuring instrument will absorb some energy for its operation, and it will affect the measured quantity, or it will affect the output of the measuring quantity. So it is called the input impedance. This impedance should be minimized. Next we shall see about the dynamic characteristics. What is dynamic characteristics? The characteristics required for a measuring instrument while measuring a constant quantity or varying quantity. So while measuring a varying quantity, what are the characteristics that is required? Number one, speed of response. That is, while measuring a varying quantity, there should be a fast response in the output. If the input changes, immediately there should be a change in the output. That is called speed of response. Second is fidelity. It is the ability of the instrument to produce a wave shape identical to the wave shape of the input. If you are giving a pure sinusoidal wave, you should get a pure sinusoidal wave in the output. Then only we can say that instrument is having a good fidelity. Then third one is lag. There are two types of lag. One is retardation lag and time delay. What is retardation lag? In some instruments, we may get the output response only after a smallest change in the input variable. Until there is a change in the input variable, there will not be any response in the output. Only after the change in the input variable, we can find a change in the output response. This is due to the retardation lag. Then similarly, in some instrument, only the instrument will respond after some time. This is called time delay. Then fourth one is dynamic error. This error is due to some unknown causes. That is, we cannot find what is the reason. But if you are taking a measurement in one time and if you are taking the measurement in the other instant of time, we can find there will be a difference. This error is called the dynamic error. This error cannot be eliminated, but it can be minimized by means of proper observation. Next topic is standards. What is meant by standard? How will you define standard? Standards are the physical representation of a unit of measurement. While we are measuring a quantity, we may use standards for different measurements. There are four types of standards. First one is international standards. These international standards are maintained only in international bureaus in different countries. They are not at all used for measuring purpose. It is only for kept as a display. Next one is primary standards. These standards are maintained at national standard laboratories. In each country we may have national standard laboratories, and these primary standards are present in the national laboratories. Next is secondary standards. In some industries or in some national laboratories, they are using these type of secondary standards, and these secondary standards are used for calibration purpose and also for measuring purpose. If we want to calibrate any measuring instrument, we have to take our instrument to these laboratories, and we can compare with these secondary standards and we can calibrate our instrument. Then last one is the working standards. This is the standard that what we are using for measuring purpose. So what are the standards that we are using for measuring purpose comes under this working standard category. Next we shall see about error and types of error. What is meant by error? It is the difference between the true value of the variable and the value indicated by the instrument, or the true value and the measured value. The difference is called error. There are three main categories of error. Number one is gross error, second systematic error, and third one is random error. Let's see one by one. First one is gross error. This gross error is mainly due to the human mistakes. It is not because of the instrument. If the person who is taking the reading is having a lack of experience and he don't know how to operate the instrument, this type of gross error will occur. And it is also mainly due to careless mistakes. So these types of error can be eliminated, but it can be reduced. It cannot be eliminated, but it can be minimized. Second one is systematic error. Under systematic error, there are three further categories. First one is instrumental error. Instrumental error is due to aging of instrument, old instruments. In old instruments, the spring tension will get reduces and it leads to error. Or misuse of instrument. If the person don't know sometimes how to correct the zero correction or how to handle the instrument, so this type of instrumental error will happen. Or due to loading effects. For a suitable measuring, we have to choose the suitable measuring instrument. If we are loading an instrument above the capacity, above the ability, the loading effect problems will happen, and that leads to instrumental error. The next type of error is environmental error. Environmental error is due to the environmental factors like temperature, pressure, humidity, pH value, electric and magnetic fields, etc. So you can avoid this type of environmental errors by enclosed boxes. If you are keeping the instrument inside enclosed wooden boxes, we can avoid these type of electric fields or magnetic fields, and it cannot be affected by temperature, pressure, etc. Then third one is observational error. Observational error is the mistakes done by the observer. The observer should watch the readings in a correct position at the correct angle, or otherwise the parallel axis error will happen. So it can be avoided by means of having proper mirror selection, etc. The last category is the random error. The random error is due to unknown causes. If the error is not an instrumental error and it is not an gross error, even though if any error occurs, that comes under random error category. So this error cannot be corrected, but it can be reduced by increasing the observations. We have to take repeated readings and we can minimize this type of random errors. Next, the topic is moving coil instruments. First we shall see about the permanent magnet moving coil instrument, PMMC instruments. This PMMC instruments is mainly used to measure DC measurements. It is used to measure DC currents, DC voltages, etc. And this PMMC instrument works on de-Orson principle. It works on de-Orson principle. What is de-Orson principle? When a current carrying coil is placed in a magnetic field, this coil experiences a force. If a current carrying conductor or coil is placed in a magnetic field, a force is exerted on the coil. Next, if you see the figure and the construction, the main parts are, first one is the magnetic system. We can see a permanent magnet that is the U-shaped magnet that is producing the magnetic field. Next is the moving coil. You can see a rectangular foil or rectangular coil that is placed in between the magnetic system, and this coil is suspended by means of two jewel bearings in the top and the bottom, so that it is free to rotate. It is not fixed, it is suspended, so it can move freely here and there. And this coil is connected to a spindle, and the spindle is connected to the pointer, and the pointer moves over the graduated scale. This is about the construction. And more than that, you can find some control springs. Now let's see the working. When the current what we are measuring, or the voltage what we are measuring, that if the current passes through the coil, it becomes a current carrying coil. And when this current carrying coil is, since it is kept in the magnetic field, by means of D'Arsonval principle, the deflection takes place in the coil. A force is exerted on the coil and the deflection takes place. So the spindle moves and the pointer moves over the graduated scale. Now, in each and every instrument, indicating instruments, there are three types of torques. First one is the deflecting torque. That is the torque required to move the pointer from the zero towards the measured value. Second one is the controlling torque. This torque is required for any measuring instrument to stop the pointer at the correct particular reading, or otherwise the pointer will continue to move. So at the proper position we have to stop the pointer. So we need a controlling torque. It is provided by means of the controlling springs. The third one is the damping torque. The damping torque is required for the pointer to stop without any oscillations. We have to stop at the particular reading without any oscillations. For that we are using an aluminum former control. This torque will provides the damping, reduces the damping effect. Next we are going to see about the moving iron instruments. Normally moving iron instruments are used to measure both AC and DC voltage and currents. There are two types of moving iron instruments. Number one, attraction type moving iron instrument, and number two, repulsion type moving iron instrument. First we are going to see about the attraction type moving iron instrument. Look at the figure. Here you can see the parts of attraction type moving iron instrument. In the figure you can see a set of rectangular core, and inside the core you can see the red color dots that represents the winding. Next is the moving iron. A flat disc shaped moving iron is present, and next there is a control weight, balancing weight, and air damping chamber, pointer, scale, etc. These are the parts of this attraction type moving iron instrument. Next is the working. In the working, the moving iron is drawn into the field of the coil when the measuring current flows. When the measuring current flows through the coil or winding, it gets magnetized and it will attract the moving disc, flat moving disc towards the coil, and which makes the pointer to shows the deflection. This movement takes place from a weaker magnetic field that is outside the coil and a strong magnetic field inside the coil. So in the weaker magnetic field, the disc is present, the moving iron is present, that is attracted towards the stronger magnetic field inside the coil. I have told you there are three types of torque. The deflecting torque, that is required to move the pointer from the zero towards the reading. Next is the controlling torque, that is to stop the pointer at the particular reading. In this attraction type instrument, it is provided by means of a gravity control. Then damping torque is provided to stop the oscillations, and here we are using a air friction damping system to avoid the damping oscillations. Next is the repulsion type instrument. Repulsion type instrument, the construction is somewhat different from the attraction type instrument. Here you can see a horseshoe shaped field coil, and there are two vanes that are connected with the field coil. One is the fixed vane that is attached to the field coil, and another one is the movable vane that is attached to the spindle. This is about the construction. Next, if you look at the working, when the measuring current flows through the field coil, it gets magnetized, and both the vanes also get magnetized simultaneously. And a force of repulsion is created between the fixed vane and the movable vane. The fixed vane will repulse the movable vane away from the fixed vane. When the movable vane moves away from the fixed vane, the spindle moves, and when the spindle rotates, the pointer moves, and we are getting a deflection over the graduated scale. Thus, we are getting the readings in the repulsion type instrument, and also there is a control spring that provides the controlling torque. So, in this lecture, we have covered the topics: what is meant by measurement, types of measurements, then characteristics of measurements, different types of standards, different types of errors, and the construction and working principle of moving coil instruments and moving iron instruments. Thank you for watching. Thank you.